The motorcycle industry of the late 1960s was governed by a complacent aristocracy that fundamentally believed rider suffering was an unalterable law of physics. If you walked into an American dealership during this era, you were likely met by the imposing presence of a Harley-Davidson FLH Electra Glide, a massive agricultural touring machine that prioritized nostalgic aesthetic tradition over actual mechanical efficiency. Across the Atlantic, the British executives at Triumph and BSA stubbornly clung to their aging parallel twins, operating under the arrogant assumption that severe engine vibration, catastrophic oil leaks, and fragile electrical systems were simply the accepted price of admission for riding a machine with authentic character. The established corporate boardrooms in Milwaukee and Meriden genuinely believed that Japanese manufacturers would forever remain confined to producing small, stamped steel, small displacement commuter motorcycles meant strictly for college students and urban delivery drivers. But that comforting, arrogant illusion was violently shattered late in 1968 at the Tokyo Motor Show, ushering in a brutal technological paradigm shift that the old guard was entirely unprepared to survive. When Honda pulled the sheet off their new flagship motorcycle, they did not merely introduce another product to the market. They dropped an engineering anvil directly onto the heads of the global motorcycling establishment. The machine sitting under the bright exhibition lights was the Honda CB750 Four, an intimidating mass of aluminum and chrome that looked less like a traditional motorcycle and more like a piece of Grand Prix racing exotica adapted for the public highway. This motorcycle forced a central conflict that would define the next 2 decades of two-wheeled history: the fierce battle between the raw, visceral, imperfect character of traditional mechanical engineering and the clinical, devastating superiority of mass-produced Japanese high technology. If detailed technical breakdowns of motorcycle history and classic American iron interest you, subscribe, because I have got more of these deep dives coming. To truly comprehend why this specific machine triggered an existential panic among domestic manufacturers, we must look past the gleaming four into 4 exhaust pipes and dissect the fundamental internal architecture of its revolutionary power plant. At a time when a heavily modified American 74 cubic inch V-twin produced roughly 60 horsepower while violently shaking its own chassis fasteners loose, the Japanese engineers delivered a staggering 67 horsepower from a relatively modest displacement of 736 cubic centimeters. They achieved this immense power output not by resorting to massive, heavy pistons, but through a brilliant exercise in volumetric efficiency and high revolutions per minute. By utilizing a transverse inline four-cylinder engine design capped by a sophisticated overhead camshaft, the factory engineers eliminated the heavy reciprocating mass of traditional pushrods and rocker arms that inherently limited the operating speeds of American and British engines. The new overhead camshaft design allowed the 4-cylinder engine to spin freely to an astonishing 8,000 revolutions per minute, a speed that would have instantly caused a traditional pushrod 5 twin engine to suffer catastrophic internal valve float and self-destruct. However, spinning an engine to those extreme speeds required a completely different approach to the lower end of the engine cases, fundamentally changing how motorcycle crankshafts were manufactured. Traditional American and British twins utilized built-up crankshafts composed of multiple heavy steel pieces pressed together and riding in simple roller bearings, a primitive design that inevitably flexed, twisted, and warped under sustained high-speed highway loads. The Japanese engineers entirely discarded this antique philosophy, opting instead to utilize a single-piece forged steel crankshaft that rode in automotive-style plain bearings. This massive leap in metallurgical engineering required the implementation of a high-volume, high-pressure internal oiling system designed to maintain a microscopic hydrodynamic wedge of lubricant between the bearing shells and the crank journals at all times. By treating engine oil as a vital structural component rather than just a slippery afterthought, Honda forever eliminated the primitive total loss oiling systems and unreliable splash lubrication compromises that plagued the traditional motorcycle industry. But this relentless pursuit of smooth, high-revving, leak-free power came with a hidden engineering cost that completely alienated the traditional roadside shade tree mechanic. To properly feed 4 hungry cylinders operating at high speeds, the engineers had to utilize a bank of 4 individual Keihin carburetors, mechanically linked together by an incredibly complex array of synchronized cables, brass linkages, and heavy return springs. A traditional American wrench turner, who was deeply accustomed to tuning a single brass Linkert carburetor on his Harley-Davidson using nothing more than a flathead screwdriver and a keen ear for the exhaust note, was suddenly faced with an intimidating, impenetrable wall of Japanese precision. Synchronizing these 4 individual carburetors required the use of a specialized bank of mercury vacuum gauges to ensure that each cylinder pulled the exact same amount of air and fuel at any given throttle position. If those 4 intricate carburetors fell even slightly out of perfect synchronization, the legendary glass-like smoothness of the inline 4-cylinder engine vanished instantly, replaced by a hunting, surging idle and a frustrating, dangerous hesitation off the throttle. Furthermore, the incredibly tiny internal brass passageways of those Keihin carburetors were highly susceptible to clogging if the motorcycle was left sitting over the cold winter months with untreated, degrading fuel in the teardrop gas tank. The independent rider, who previously took immense personal pride in executing roadside repairs using nothing more than a crescent wrench and a pair of pliers, suddenly found himself completely locked out of his own motorcycle's tuning process. The romantic era of fixing a stranded motorcycle on the dirt shoulder of a desert highway with baling wire, electrical tape, and sheer mechanical intuition was officially coming to an abrupt end. The technological assault did not stop at the intricate fuel delivery system. It continued down to the front wheel, where the Japanese engineers introduced the first hydraulic front disc brake ever fitted to a mass-production mainstream motorcycle. For decades, the manufacturers of heavy American touring cruisers relied exclusively on mechanically actuated drum brakes, which functioned reasonably well at low urban speeds, but suffered from severe, life-threatening thermal degradation during aggressive, high-speed riding. When a massive, heavy machine like a Harley-Davidson FLH Electra Glide was hustled aggressively down a steep, winding mountain pass, the immense mechanical friction would heat the heavy cast-iron brake drum, causing the metal to physically expand and pull away from the internal brake shoes. This terrifying phenomenon, widely known among seasoned riders as brake fade, resulted in a sudden catastrophic loss of stopping power right at the exact moment the rider needed it most desperately. The new Japanese braking system fundamentally solved this thermal crisis by utilizing a single-piston hydraulic caliper that clamped down heavily on an exposed, spinning stainless steel rotor. Because the friction material was grabbing the outside of the metal disc as the components heated up under heavy use, the thermal expansion actually worked to the rider's advantage by swelling the metallic rotor outward toward the brake pads, entirely eliminating the concept of structural brake fade. But this massive, necessary leap in braking technology came with a viciously steep learning curve and a severe hidden price that had to be paid every time the sky turned dark and the rain began to fall. The solid, undrilled stainless steel rotor utilized by the factory engineers offered virtually zero initial friction bite when it was soaking wet, meaning a rider caught in a sudden highway downpour would squeeze the front brake lever and experience absolutely nothing for several agonizing, terrifying seconds. The solid metal rotor had to complete at least one full high-speed rotation against the abrasive brake pads simply to act as a squeegee and wipe the standing water off the metal surface before any actual mechanical deceleration could finally begin. Knowing what you now know about its real-world handling and reliability, would you still want this parked in your garage today? Share your thoughts below. because while the brilliant power plant and stopping technology were hurtling the motorcycle industry deep into the future, the physical chassis carrying all of this technology was desperately trying to drag it back into the primitive past. The tubular steel double cradle frame wrapping around that massive engine was fundamentally inadequate for the immense torsional twisting forces generated by 67 horsepower, suffering from painfully thin-walled steel tubing that physically flexed under hard cornering loads. When an enthusiastic rider pushed the nearly 500-pound machine aggressively through a sweeping canyon curve at high speeds, the immense engine power would twist the swing arm pivot and bend the frame backbone, initiating a rhythmic, terrifying oscillation directly through the handlebars. This violent high-speed wobble, infamously described by period journalists and terrified test riders as feeling like the motorcycle was physically hinged in the middle, forced a brutal, unavoidable realization upon the riding public. The Japanese engineers had brilliantly mastered the highly complex thermodynamics of the internal combustion engine and the fluid dynamics of hydraulic braking. But they still had absolutely no idea how to design a rigid chassis or calibrate suspension damping for aggressive cornering. The rear suspension units, known colloquially on the showroom floor as shock absorbers, were barely more than glorified, heavy-duty springs filled with cheap, low-grade hydraulic fluid that rapidly overheated, foamed up, and lost all structural damping capability over rough, broken pavement. Riders quickly learned that this was a motorcycle designed to travel in a perfectly straight line at incredibly high speeds. But asking it to rapidly change direction on a bumpy rural road was an invitation to a violent high-side crash. This terrifying high-speed handling deficit brings us directly to the operational reality of actually living with and maintaining this machine, where another fatal flaw in the drivetrain began to emerge under the stress of daily abuse: the massive amount of low-end torque produced by the transverse four-cylinder engine absolutely shredded standard, conventional drive chains, which simply had not been engineered by the industry to handle that continuous level of violent mechanical stress. Riders who purchased this machine thinking they were finally escaping the endless, dirty maintenance of a vibrating British parallel twin suddenly found themselves constantly carrying a heavy wrench just to adjust their continuously stretching rear drive chain on the side of the road. If the rapid stretching of the drive chain was ignored by a careless owner for even a few hundred miles, the chain would eventually snap violently under hard acceleration, frequently whipping forward to crack the fragile aluminum engine cases and causing a catastrophic, unrepairable loss of engine oil. Despite these glaring chassis flaws and drive chain nightmares, the actual sensory experience of throwing a leg over the saddle and starting the machine was a revelation that instantly made traditional motorcycles feel like antiquated farm equipment. Consider the grueling morning ritual of a traditional American rider walking out to his cold garage to start a high-compression Harley-Davidson XLCH Sportster in the late 1960s. The starting process demanded a violent, almost religious physical choreography that required absolute dedication. Turning on the fuel petcock, fully retarding the manual ignition spark lever on the handlebars, tickling the carburetor until raw, highly flammable gasoline dripped openly onto the hot engine cases, and painstakingly finding exact top dead center on the heavy steel kickstarter pedal. If the rider's heavy leather boots slipped off the pedal, or if the manual ignition timing was advanced even a fraction of an inch too far, the massive high-compression V-twin engine would violently backfire. This backfire would instantly throw the heavy steel kickstart lever upward, directly into the rider's shin or knee, with enough blunt force to shatter bone and tear ligaments. Now contrast that brutal, sweaty, dangerous endeavor with the clinical, effortless, and almost polite reality introduced by the Japanese engineers on their new four-cylinder flagship. A rider sitting on the wide, comfortable saddle of the new machine simply turned a small metal ignition key, pulled a conveniently located choke lever, and pressed a small plastic button with his right thumb. This simple action prompted a highly reliable 12-volt electric starter motor to seamlessly spin the massive engine to life with a quiet, efficient whine, settling immediately into a smooth, high-pitched mechanical hum that sounded more like a European sports car than a traditional motorcycle. There was no bone-shattering kickback, no pools of leaking oil staining the concrete garage floor, and no violent shaking of the handlebars at idle to blur the rider's vision in the rearview mirrors. This absolute lack of engine vibration completely revolutionized the concept of long-distance motorcycle touring, changing the demographic of who was actually willing to ride a motorcycle across the country. On a rigid-mounted 74 cubic inch American V twin, the severe mechanical vibration transferred directly through the steel frame into the rider's hands, feet, and spine, frequently causing total nerve numbness and deep physical fatigue after just 100 miles of highway cruising. By contrast, the perfectly balanced internal architecture of the Japanese inline-four cylinder engine operated with such profound, turbine-like smoothness that a rider could cruise comfortably at 70 miles per hour all day long, arriving at their destination without feeling like they had just survived a bare-knuckle boxing match. The exhaust note exiting through the symmetrical 4x4 exhaust pipes was not the syncopated, menacing potato-potato rumble of an American cruiser, but rather a sophisticated, high-pitched turbine howl that announced the arrival of a completely new era of mechanized transport. While Honda was busy confidently rewriting the basic rules of physics, thermodynamics, and consumer expectations, the traditional executives in Milwaukee were fighting a desperate, losing battle for mere corporate survival. In 1969, the exact same year the new Japanese four-cylinder machine hit dealership showroom floors across the country, a financially struggling Harley-Davidson was formally acquired by American Machine and Foundry, effectively ushering in the deeply controversial, widely despised AMF era of American motorcycling. As Japanese motorcycles flooded the domestic American market with their push-button electrical reliability, leak-free horizontally split engine cases, and pristine manufacturing tolerances, Harley-Davidson was actively suffocating under catastrophic quality control issues, outdated manufacturing tooling, and a deeply demoralized union workforce. The infamous AMF-era shovelhead engines produced during this dark period were widely notorious for weeping fresh oil onto dealership showroom floors before they were even sold to their first unsuspecting customer. Their massive, outdated electrical generators frequently struggled to produce enough voltage to keep the heavy lead-acid battery sufficiently charged during low-speed urban cruising, often leaving riders stranded at traffic lights with dead engines. Against this bleak backdrop of domestic industrial decay and compromised engineering, the sudden arrival of the clinical, precision-engineered Japanese four-cylinder machine felt significantly less like fair, open-market competition and significantly more like a hostile, unstoppable alien invasion. Harley-Davidson found themselves completely incapable of competing on the grounds of outright horsepower, mechanical reliability, or pricing, forcing them to retreat inward and rely almost exclusively on heavy import tariffs, fierce brand loyalty, and traditional American nostalgia just to keep their factory doors open. The British motorcycle industry fared considerably worse in the face of this overwhelming Japanese technological assault, suffering a total structural collapse from which they would never truly recover. The historic Marques of Triumph, Norton, and BSA desperately attempted to answer the four-cylinder threat by rushing their own multi-cylinder machines to the market, resulting in the incredibly flawed Triumph Trident and the similarly doomed BSA Rocket 3. But these desperate reactionary British machines were essentially just aging, vibrating, push-rod-actuated engines that still fundamentally relied on vertically split engine cases that leaked oil profusely and ancient electrical systems created by Lucas Industries, infamously known among frustrated riders as the Prince of Darkness. When parked directly next to the sleek, oil-tight overhead camshaft Japanese machine with its glowing electric starter button and modern front disc brake, the newly released British triples, visually and mechanically, appeared as though they were leftover relics, dredged up from 1959. This devastating market dominance established a powerful, enduring architectural blueprint that would dictate global motorcycle design for the next 30 years, birthing a concept that industry journalists would soon categorize as the universal Japanese motorcycle. The formula was relentlessly standardized across all major competing brands: a transverse inline four-cylinder engine, an overhead camshaft valve train, a tubular steel cradle frame, a front disc brake, and entirely completely reliable 12-volt electrics. Kawasaki soon answered the challenge with the legendary Z1, pushing the displacement up to 903 cubic centimeters and adding dual overhead camshafts, entirely validating the inline-four architecture as the absolute pinnacle of high-performance motorcycle engineering. Suzuki and Yamaha were ultimately forced to abandon their historic dedication to lightweight, peaky two-stroke engines and eventually join the four-cylinder, four-stroke arms race, permanently shifting the global epicenter of motorcycle development from the aging brick factories of the American Midwest and the British Midlands directly to the high-tech industrial manufacturing hubs of Japan. Looking back at this massive historical disruption through the critical, analytical lens of a historian, the central conflict between traditional character and clinical perfection was ultimately resolved by the unforgiving reality of the free consumer market. The Honda CB750 Four was absolutely not a flawless, perfect machine. Its heavy steering geometry was agonizingly sluggish at low speeds. Its flexible steel frame was dangerously unstable during high-speed cornering, and its solid stainless steel front brake rotor was genuinely terrifying in a heavy rainstorm. It sacrificed the low-end, visceral, chest-thumping torque of a traditional American V-twin for high-revving, clinical horsepower, forever altering the sensory feedback that defined what a motorcycle was supposed to feel like. But despite all of these inherent documented flaws, it fundamentally destroyed the long-standing, arrogant myth that high-performance motorcycles inherently had to be unreliable, vibrating, oil-leaking burdens that demanded constant mechanical sacrifice from their owners. It successfully forced the surviving American and European manufacturers to completely modernize their stagnant engineering departments, radically improve their disastrous quality control standards, and finally treat the motorcycle rider as a valued consumer rather than a hostage to heritage. It was the devastating extinction-level event that wiped out the dinosaurs of the old guard, dragging an entire reluctant industry kicking and screaming into the modern technological age. If you found this analysis useful, a like helps more people discover these deep dives. Thanks for watching.